Hey guys! Video 7.5, Proportions and Triangles. Welcome back to the lovely sound of my voice. Let's talk about the Sidesplitter Theorem. So, Sidesplitter. It's going to sound complicated until you actually see it in the image below. If a line is parallel to one side of a triangle, alright, so they're parallel, and intersects the other two sides, then it divides those sides proportionally. Okay, so here's our triangle. And this guy right here that slices through would be your side splitter, quote unquote. And it's parallel. That means that RQ and XR are proportional to each other, which are also proportional to YS and SQ. So side splitter theorems. You'll learn that as in the practice test that I gave you. That's how you can set these things equal to each other, even though it's not an entire side, or proportional to each other, excuse me. And then the corollary, I have the hardest time saying those, is if three parallel lines are intersected, you have more than, in one of your practice problems, you have three sets of lines like this. Two transversals and the segments intercepted on the transversals are proportional. So that's just saying if I have a set here and a set here and then a set down here, they're all proportional. So you can use all of those as a proportion. So here I'm just giving you, rather than a triangle, I'm showing you three lines that are parallel to one another. So A to B, you would set up as proportional to B to C, and you could also say that that is equal to WX to X to Y in that proportion, right? As long as these are parallel to each other, which it will tell you in the diagram. Okay, so then we move along to the triangle angle bisector theorem. The bisector of an angle of a triangle divides the sides into two segments that are proportional to the other two sides of the triangle. So here's the angle bisector, right? We see that it's slicing through, and as a result, there's an angle here that's congruent and an angle here that's congruent. Well, not only does it do that, but it also creates some proportions. We could then say that this portion, CD, would be the numerator in our ratio, would be over DB, the denominator of our ratio, and then we could say CA is over BA. We could go ahead and solve for X if that was the case. This pink portion over this pink portion would be equal to this green portion over this green portion. This would also be true for an altitude and a median. Let's look at some examples dealing with these two theorems. All right, so you're going to see my work here, which is fine. You're more than welcome to look ahead. All right, I'm not going to make you solve them this time, but this might help you in the practice test that you're working on. Sorry, it's a little blurry. Let's see if we can't get it to focus. Oh, that's better. So what I did is I just took one side and I went ahead and highlighted that in pink. And I went ahead and did 12 over x plus 1. And for this other side of this triangle, I set it equal to 9 over x. It's really important that if I start with this part of the triangle on top, that I continue that with my other ratio with 9 on top and these two smaller pieces on the bottom. I'm going to cross multiply, so 12 times x, 12x, and 9 parentheses x plus 1. Don't forget to distribute to both numbers, not only the x, but the 1 as well. So we end up with 12x equals 9x plus 9. I want to get my x over on the other side, so subtract 9x and subtract 9x. I end up with 3x equals 9. Divide by 3, x equals 3. All right, and we move along here, and we say solve for x again. Well, this time I'm going to stick with the bottoms. I'm going to use the two bottom pieces that I highlighted in green, or top if you will, but to me that looks like the bottom of a triangle. And I'm going to put the smaller one on top and the larger one on the bottom. All right, well, since this 10, this one in green, was kind of aligned with the smaller triangle, I'm going to set it equal to 12, which is aligned with the smaller triangle. And then since the 18 was kind of aligned with this bigger triangle, I'm going to put it over the x of this bigger triangle. I'm going to cross multiply again. I'm going to get 10x equals 12 times 18. So 10x equals 216, divide by 10, x equals 21.6. Hopefully those help you with the two problems in your practice test. You will see some problems like this on your test. So just keep in mind that proportions are created with the Sidesplitter theorem, right? And you don't have to know the whole side to be able to solve. And that's it, guys. See you Monday.